PU2 champions, welcome to day 4 of 21 days challenge to get 95% in your second PUC final board exams. So as part of today's challenge, I have given you 2 chapters for homework. The first one, coordination compounds from chemistry and current electricity from physics, right? So you have to revise these 2 chapters and practice the most important questions from the PDF I have provided. Okay, if you haven't downloaded yet, the link is there in the description section. So please click on the link, go to the page and download the most important questions PDF and practice those questions at any cost. Okay, it is very important because I have selected so many resources which are like PYQs, your model question papers, question bank, passing package and everything, and have prepared the most important questions. You need to practice those questions. Okay, so in this video, I'll be talking about the most important questions from the chapter current electricity. And as all of you have requested to give the answers for numericals, that is also done in this particular video. Okay, so let's understand the blueprint of this chapter. And before that, to track your progress in this 21 days challenge, I have prepared a tracker for all of you. The link of this tracker is also there in the description section. You can download it, create a copy of it. Please understand, create a copy of the tracker so that you can use it according to your pace. So whichever challenges you have completed, whichever chapters revision and question is done, you can just put a tick mark on this tracker and then you can track your progress. So now let's understand the blueprint of this chapter. So the total weightage of this chapter is 13 marks. Okay, so let me just, yes, so there are 2 5-marker questions that gives you 10 marks. So there will be 1 derivation and 1 numerical. Okay, then 1 2-marker question, so 12 marks, and 1 1-marker question. Okay, so now let's first tackle this bigger part, that is 5-marker questions and all the theory questions, derivations that is possible with the years they have been asked. I have mentioned here. The first question is to calculate or to find the expression for drift velocity, derive the expression for conductivity of a material where the symbols have the usual meaning. Sorry, assuming the expression for drift velocity, you have to derive the expression for conductivity of a material and you have to define the term mobility. You can see this question was also asked in April 2025 paper. Next, using Kirchhoff's law, arrive at the balancing condition of the Wheatstone network. This is also important question and it is asked in model question paper 3 of 25-26 academic year. Then obtain the expression for equivalent EMF and equivalent internal resistance of 2 cells of different EMFs and different internal resistance connected in series. Okay, this is an important question asked in model question paper 2. Assuming the expression for drift velocity, derive the expression for the conductivity of a material. That is the same as the first question, but I have repeated it because here the expression is already given and you just need to prove it. Okay, so this was asked in model question paper 1. Next, derive an expression for the electric current in terms of drift velocity and the number density of the free electrons. Derive the expression for the equivalent EMF and internal resistance of 2 cells connected in parallel. So you can see in model question paper 2 it was asked for series and in exam it can be asked for parallel as well. So prepare all these 6 derivations thoroughly. Now coming to one important announcement here, as there is a lot of pressure at this point of time, too many confusion, panic with just 25 days left for your final board exams. I think that at this point of time, you all need a right strategy and most importantly, right guidance. So if you are confused about your preparation, stressed about your preparation, do not worry. I am there to help you. You can book this one-to-one mentorship session with me where we can discuss all your problems in detail and I guarantee you to provide the best solution for your problem. We will be discussing about your study plan, study subject-wise strategies, and I'll clear all your doubts, including your chemistry academic doubts. Okay, so if you need this, if you want a right guidance, if you are just stuck in between your preparation and you want some help, the link is there in the description section. So please click on the link and book a one-to-one mentorship session. Okay. Now let's talk about the 5-marker numerical question. So here the first question is two identical cells, each of EMF 15 volt, either connected in series or connected in parallel across an external resistance of 5 ohm, produce the same current through the resistor. Calculate the value of internal resistance of the cell and also calculate the current through the external resistors in either case. So here the answer I have also mentioned. So please first solve the question and then check the answer. Next, two cells of 8 volt 1 ohm and 10 volt 2 ohm are connected in parallel such that they send a current in the same direction through an external resistance of 20 ohm. Find the current and the potential difference across 20 ohm. Here also I have given you the answer. Next is two identical cells either connected in series or in the parallel combination give the same value of current of 0.45 ampere through an external resistor of resistance 2 ohm and find the EMF and the internal resistance of each cell. Okay, here also I mentioned you the answer. Now this particular question is accordance to this diagram. You have to find the current passing through the galvanometer. Next, the resistance of a platinum wire of platinum resistance thermometer at ice point is 5 ohm and at steam point is 5.23 ohm. When the thermometer is inserted in a hot bath, the resistance of platinum wire is 5.795 ohm. Calculate the temperature of the hot bath. Okay. Next is question from the number of electrons and density of electrons. A copper wire has 3 into 10 to the power of 22 free electrons in 0.021 meter length. The drift velocity of the electrons is found to be 2 into 10 to the power of minus 5 meter second inverse. How many electrons would pass through a given cross section of the wire in 1 second? Okay, so here the answer is given to you. A copper wire has a diameter of 0.5 millimeter and a resistivity of 1.68 into 10 to the power of minus 8 ohm meter. What will be length of this wire to make its resistance 2 ohm? How much does the resistance change if the diameter is doubled? Okay, these all questions are very basic and easy questions. A battery of 6 volt gives a current of 2 ampere when connected to a resistance of 2 ohm. What is the internal resistance, terminal potential difference and the lost voltage of the battery? Next, in a Wheatstone bridge, resistance R1, R2, R3 and 4 are 10, 20, 30 and 50 ohm respectively. Is the network balanced? If not, how do you vary the arm R3 and the arm R4 to balance the network? Okay, so these are some 9 numericals from your model question paper, previous year questions and passing package. Now we'll be doing model question papers. Also, I have taken it separately. You can see the terminal potential difference of a cell connected to an external resistance of 4 ohm is 2.4 volt. When the same cell is connected to an external resistance of 9 ohm, the new terminal potential is 2.7 volt. Find the EMF and the internal resistance of the cell. Next, a copper wire of length 50 centimeter at diameter 1 millimeter carries a current of 3 ampere. The number density of free electrons in copper is 8.5 into 10 to the power of 28 meter cube. Now here you have to calculate the current density, drift velocity and the time taken by the electrons to drift from one end of the wire to the other end. Okay. Now calculate the power dissipated in the 10 ohm resistor in the given circuit. So here it is the 10 ohm resistor. With respect to this, you have to find the power dissipated here. Okay. Now there are no 3-marker question in this chapter. So there are 2-marker question, a lot of definition, formula, SI unit based questions are there. So first one is give any 2 limitations of Ohm's law, what is ohmic device and give an example. Okay, you can see this question is so much repeated. So very important question. Next, define mobility, drift velocity and its SI unit. Write the expression for the drift velocity in terms of current and explain the terms used. State and explain Kirchhoff's law. Represent graphically the variation of resistivity with absolute temperature for copper and nichrome metal. Okay, I have taken this question again also separately. So you can see a large number of free electrons are present in the metal. Why is there no current in the absence of electric field? State and explain Ohm's law. How does the resistance of a conductor vary with its length and the area of cross section? Mention the expression for resistance in terms of resistivity and explain the terms. Define electrical resistivity and its SI unit. Mention any 2 factors on which the resistivity depends. Write any 2 differences between resistance and resistivity. Define electrical conductivity. Mention its SI unit. Define current density in a conductor and mention its SI unit. Write another equivalent form of Ohm's law in terms of current density and conductivity and explain the terms. Next is write any 2 limitations of Ohm's law. What are ohmic and non-ohmic devices? Give an example of each. Draw the VI graph for an ohmic and non-ohmic material. Define the terms drift velocity and relaxation time. Define mobility and give its SI unit. Obtain the expression for mobility of free electrons in terms of relaxation time. Then you have write the expression for resistivity in terms of number, density and relaxation time and explain all the terms. What is the cause of resistance of a conductor? Write an expression for the resistivity of a metallic conductor showing its variation over a limited range of temperature and explain the terms. Next is how does the resistivity of a metal copper? I told you I have taken these 2 questions separately. Copper vary with temperature. Show its variation graphically. How does the resistivity of alloys vary with temperature? Show its variation graphically. Next, some more questions are there. How does the resistivity of a semiconductor vary with temperature and show its variation graphically? Define electrical energy, electrical power. Mention the expression of power loss. Why high voltage from power generating station is preferred than high current for transmission of electrical power. Define EMF and internal resistance. Terminal potential difference is less than the EMF of a cell. Why? What is the basic purpose of cells connected in series and in parallel? Then state and explain Kirchhoff's junction rule and the loop rule. Okay, so these are the 2 marker questions. Almost 35 questions are there. Just prepare these many questions, then your entire current electricity chapter will be done. And as I told you, the mentorship program is already there. If you need any help, you can contact me. The link is there in the description section. Okay, please book a session, and if required, I can help you in the best possible way. The challenge page is also there in the description section. The tracker is also there in the description section, so please go and check out, track your progress, and make sure that you make the best utilization of the next 25 days for your final board exams. Okay, all the best, my dear children. Thank you so much, and keep learning and keep working hard.